7.7 practice problems. A 0.1 mole sample of each of the four species is in the reaction represented above is injected into a rigid, previously evacuated 1 liter container. Which of the following species will have the highest concentration when the system reaches equilibrium? So the 0.1 molar means that we are equimolar, and we can see that as I proceed forward, my balanced chemical equation, I have 2 of the hydrogen sulfide for every 1 of the methane. And so that means if 0.1 of the hydrogen sulfide was put in, then I am going, and 0.1 of the methane was put in, I have approximately twice the number of hydrogen sulfide than methane that is needed for the reaction, meaning that at equilibrium 0.05, or sorry, if I were to push to completion, only half of this would be used, whereas all of this would be used. However, my K constant is very, very small, which does mean that I am not going to push to completion. However, my overall statement that I'm going to have definitely more of the hydrogen sulfide than the methane is true, and then I am definitely not going to have a lot of products. So the hydrogen sulfide is going to be the thing that I have the most of, just because of the balanced chemical equation, and then also because my K value is so small, I know that I'm going to have more reactants than products. A certain gas XY decomposes as represented by the equation above. A sample of each of the 3 gases is put in a previously evacuated container. The initial pressure, partial pressure of the gases are shown in the table opposite. The temperature of the reaction mixture is held constant. In what direction will the reaction proceed? So we see that our initial pressures here is that we have a lot more of our products than we have of our reactants, and that our overall K value is relatively high, 230. So at equilibrium, my K being 230 needs to have my products, which are my concentration of X and Y, over my concentration of my reactants, which is XY, and then that will be raised to squared. This is at Q, not K though. And to determine which direction this reaction is going to go, I need to compare the K value of 230 to the current Q value. So Q is going to be equal to the concentration of X, which is 0.2, times the concentration of Y, which was 2, divided by my concentration of XY squared. So 0.2 times 2 divided by 0.01 squared gives me a Q value of 4,000, which means that I have substantially more products at that current time at Q than I should have at the time of equilibrium, which means that I am going to shift to the reverse reaction, and I am going to reform more of my reactants so that I can get my equilibrium constant back in line with what it should be. Equal number of moles of hydrochloric acid and oxygen are in a closed system are allowed to reach equilibrium as represented by the equation above. Which of the following must be true at equilibrium? So I'm going to look at my balanced chemical equation. I see that I have 4 hydrochloric acids for every 1 oxygen, for every 2 chlorines, and for every 2 waters. So it states for number 1 that hydrochloric acid must be less than chlorine. I don't have my K value, so I actually don't know if I am favoring more of my reactants or products. So I do not know that. I'm going to say no there. Then it says that for 2, that the concentration of oxygen must be greater than that of the concentration of the hydrochloric acid. So now I am comparing side by side here. And I do need 4 more hydrochloric acids than oxygens. And then statement 3 is that chlorine must be equal to, the concentration of chlorine must be equal to the concentration of water. So 2 and 3 are both true, so therefore D is going to be my answer choice there. The synthesis of CH3OH from carbon monoxide and hydrogen is represented in the equation above. The value for K, for the concentration at 483 Kelvin, is 14.5. A 1 mole sample of carbon monoxide and a 1 mole sample of hydrogen are pumped into a rigid, previously evacuated 2-liter vessel at 483 Kelvin. Which of the following must be true at equilibrium? So at equilibrium, my K is greater than 1, which does mean that I am going to favor my overall concentration of products in general. Then it states that I have an equimolar concentration of carbon monoxide and hydrogen, and I know that I need twice as many hydrogens as the carbon monoxides, and so I'm going to look for something that says probably something along those lines there. I can't state the overall concentration across the yields sign. However, I can do a direct comparison of concentrations on the reactants or product side. So I know that my concentration of carbon monoxide, I am going to use up less of the carbon monoxide than I will of the hydrogen. And again, I can't state that anything will be equal. However, I can state that I am going to be using up less of the carbon monoxide than the hydrogen. And so the statement B, where the concentration of hydrogen is less than that of carbon monoxide, is going to be my best choice. At 450 degrees Celsius, 2 moles of each of the hydrogen, iodine, and hydriodic acid gas are combined in a 1-liter rigid container. The value for K at 450 is 50. Which of the following will occur as the system moves more toward equilibrium? So at this point, we are given a Q value where my concentration of my product of HI squared divided by my concentration of my reactants, the H and I, where we are not going to be squaring either of those, and the concentration of each is 2. So this is 2 squared over 2 times 2, which is just going to be 1. And then I can see that my K value is 50, and my Q value is currently much lower at 1, which means that I am going to proceed forward in the forward direction for the reaction. I'm going to produce more products. And so option choice B is going to be my best choice. At a certain point in time, a 1-liter rigid container reaction vessel contains 1.5 moles of phosphorus trichloride, 1 mole of chlorine, and 2.5 moles of phosphorus pentachloride. Which of the following describes how the measured pressure of the reaction vessel will change and why it will change as the reaction system approaches equilibrium at a constant temperature? So currently I was given Q values, and we just have the phosphorus pentachloride concentration divided by the concentration of the phosphorus trichloride and oxygen. No squaring or anything, since I don't have any coefficients there. And then I can just go ahead and plug everything in. So I have 2.5 for the phosphorus pentachloride. I have 1.5 for phosphorus trichloride, and just 1 for my chlorine. And so I will plug that in and see what we get. So 2.5 divided by 1.5 and 1 gives me 1.67, or with correct sig figs, just 1.7. So I'll just fix that. The Q value is currently 1.7. And we can see that the concentration, or the equilibrium constant, is 6.5, which is greater than that of Q, which means I am going to push forward and I am going to produce more of my products. The products, I have less individual molecules on the product side than on the reactant side, and therefore my pressure will be decreasing because K is greater than that of Q, and therefore I am producing more products, and the products, I have less molecules, which means I will have less collisions and therefore a lower pressure.